All right, let's take a look here at another example of sketching an f prime graph based on a graph of f that's a little trickier. Okay, so in the previous couple examples, we saw graphs of f that had a slope of 0 somewhere, and I always said, oh, I always like to start with that. Well, it doesn't always happen, as you'll see in this case right here. This graph right here never has a slope of 0. Okay, so we can't start with that. So we just got to kind of think about this one here, and so this graph of f, if I look to the left-hand side of x equals 0, there's no graph there. So therefore, there will be no derivative there either. Okay, there's going to be no f prime graph. This graph of f is only really defined for values of x from 0 to infinity, and not even including 0. So this graph of f prime will be there for values from 0 to infinity as well. Okay, so I look at this graph, and one thing I notice from the start is the graph of f is always positive. Okay, so the slopes are always positive. Okay, from left to right, the y values increase in value. Okay, so that means that the f prime is always going to be positive. Well, it's always going to be above the x-axis. Okay, so that right there is a key to observe, right off the bat. Okay, that I know the f prime graph is always going to be above the x-axis. And let's see here. I notice at the beginning, if I look at these slopes here at the beginning, okay, they look really, really steep. Like, for instance, if I were to try and assign a value to that, maybe that slope would be like, I don't know, m equals like 20 or something like that. Really steep, okay? And then, as I move further and further, the slope still here is pretty steep, but it's not as steep as it was before. There, the slope might be like equals like, I don't know, m equals 10 or something. And as I go further up here, now it's, flattening out a bit. Maybe there's a slope of m equals like 5 or something. And up here, it's flattened out a lot more. Maybe a slope of m equals 1. And then as I go further to the right, the slope flattens out even more and more and gets close to a slope of 0, but never actually gets there. So these are the slopes of my f prime graph. Basically the idea that from left to right, they start out really, really big at the beginning and they decrease in value. They never get quite to 0, but they decrease in value. So on my f prime graph, the x value where I drew the m equals 20 is just right after x equals 0. So just right after x equals 0, the idea is that the y value of f prime should start out really big. Okay? The reason, again, at this x value here, the slope of f is 20, approximately 20. So that means that that same x value on the graph of f prime, the y value should be 20. Remember, the y values of f prime are the slopes of f. And as I move to the right, as you'll notice here again, m equals 10. So as I move to the right, the slopes get less and less and less. And so what happens is the y values of f prime get less and less and less as I move further to the right. So the graph of f prime, if I kind of connect these dots, will look something like this. Okay? As x is close to 0, the y values of f prime are really big, corresponding to the slopes being really big of f close to 0. As x goes further to the right, the y values of f get smaller in value, corresponding to the slopes of f getting smaller in value. And you'll see here as x goes quite far to the right, the y value of f is close to 0 because the slopes of f are close to 0. So definitely tricky, but there's a kind of a tricky example for the slope.